Hey guys, welcome back to my channel. Today we'll be solving question number 10 to 15 of exercise 8B OP Malhotra's textbook for ISC Mathematics. So let's begin. Okay, so first we have question number 10, which is the differentiation of a plus x upon a minus x raised to 3 by 2. So we know that the differentiation of x raised to n is n into x raised to n minus 1. So we are going to take this entire term as x. So we have 3 by 2 into a plus x upon a minus x, the whole thing raised to 3 by 2 minus 1, which is 1 by 2, into the differentiation of a plus x upon a minus x. For this, we use the u by v rule. So we have 3 by 2 into the root of a plus x upon a minus x into, so the u by v rule states that we have a minus x into the differentiation of a plus x. We know that the differentiation of a is 0 because it's a constant, and the differentiation of x is 1, so this is basically 1, minus a plus x into the differentiation of a minus x. So this is minus 1 because the differentiation of a is 0 and the differentiation of minus x is minus 1 upon a minus x the whole square. Okay, so this becomes 3 by 2 into root a plus x upon a minus x into a minus x plus a plus x, because the minus terms become plus, upon a minus x the whole square. So this, we can see that the x gets cancelled out and we are left with 2a in the numerator, and this thing is a minus x raised to half, so we can write this as 3 by 2 into root a plus x into 2a upon a minus x raised to half plus 2 according to the rule of indices, which is basically, so let's see, half plus 2 is basically 5 by 2. So a minus x raised to 5 by 2, and this 2 will get cancelled out. So the final answer would be 3a root a plus x upon a minus x raised to 5 by 2. Okay, so now we have the 11th question, which is a square plus x square upon root a square minus x square. Again, we use the u by v rule. So we have root of a square minus x square into the differentiation of the numerator. Again, a square is a constant and the differentiation of x square is 2x minus a square plus x square into the differentiation of a square minus x square raised to half upon the square of the denominator here will be a square minus x square because it's raised to half anyway. So we have 2x root a square minus x square minus a square plus x square into 1 by 2 into a square minus x square raised to minus half into the differentiation of a square minus x square, which is minus 2x. So sorry about that. Then we have a square minus x square in the denominator, 2x root a square minus x square minus, this 2 will get cancelled. So we are left with a square plus x square upon root of a square minus x square, because if we can take this in the denominator, then it will become a positive power, and that's basically 1 upon a square minus x square raised to half, which is 1 upon root a square minus x square into minus x. So this sign becomes plus and we have an x over here and a root of a square minus x square over here. In the previous page, we had a square minus x square in the denominator. Please note, it was not root a square minus x square. So now we can make these 2 as the common denominator. So we have 2x into a square minus x square. Basically, I multiplied this term in the numerator and the denominator, plus x into a square plus x square upon, we take this term in the denominator of the main fraction, which is a square minus x square raised to half into a square minus x square raised to 1. So this becomes a square minus x square raised to half plus 1. Then we have 2x a square minus 2x cube plus xa square plus x cube upon a square minus x square raised to 3 by 2, right? So then this becomes we can have a square common, so this is 2x. Actually we can have xa square common, so this is basically 3xa square, because it's basically 2 plus 1, right? Minus x cube upon a square minus x square raised to 3 by 2. So finally we have 3xa square minus x cube upon a square minus x square raised to 3 by 2. Okay, next we have the 12th question, which is root of 1 minus x upon 2 plus x, which is basically 1 minus x upon 2 plus x raised to half. So the differentiation of that would be half into 1 minus x upon 2 plus x raised to half minus 1, which is half, into, this is basically 1 minus x upon 2 plus x raised to minus half now. So if we take the reciprocal of the fraction, that becomes 2 plus x upon 1 minus x raised to half. Then we differentiate 1 minus x upon 2 plus x, not 2 plus x upon 1 minus x. We got this just by simplifying this, just by removing the negative power of this. But we have to differentiate this thing according to the chain rule. dy dx of 1 minus x upon 2 plus x. So we have half into root of 2 plus x upon 1 minus x. Then using the UV rule, we have 2 plus x into the differentiation of 1 minus x. We know that's minus 1. Minus 1 minus x into the differentiation of 2 plus x. We know that is 1. Upon 2 plus x square. Alright. So we know that this is 2 plus x raised to half and this is 2 plus x square. So we can just cancel these and reduce the power. So let's just write it like this. Half into 2 plus x raised to half upon 1 minus x raised to half into minus 2 minus x minus 1 plus x upon 2 plus x square. So if we cancel this, instead of subtracting half minus 2, I can just take this down and do 2 minus half, right? Because of the rule of indices. So this is 3 by 2. So we have half into 1 upon 1 minus x raised to half into, now x and x cancel out, so this becomes minus 3 and 2 plus x raised to 3 by 2. So the final answer is minus 3 upon 2 into 1 minus x raised to half into 2 plus x raised to 3 by 2. That's the final answer. Let's go on to the 13th question. Okay guys, moving on to the 13th question, we have root of a plus x minus root of a minus x upon root of a plus x plus root of a minus x. So we'll be rationalizing the denominator here. So we can have root of a plus x minus root of a minus x the whole square upon root of a plus x plus root of a minus x into root of a plus x minus root of a minus x. So then we would get a plus x minus a minus x minus 2 root a square minus x square upon a plus x minus a minus x using the a square minus b square formula. So then we have a minus a will get cancelled and x plus x becomes 2x minus 2 root a square minus x square. A minus a gets cancelled and we have 2x. So we can just cancel out the 2 and we get x minus root of a square minus x square upon x. And I'm so sorry about this. This is supposed to be a plus sign. So this would become a, not x. Okay. So then we can use the u by v rule. So we have x into the differentiation of a minus root of a square minus x square, which would be 0 minus 1 upon 2 root a square minus x square into the differentiation of a square minus x square, which is minus 2x. So again 2 gets cancelled and minus minus will turn into plus. Then we have minus a minus root of a square minus x square into the differentiation of x, which is 1, upon x square. Okay, so then we get, this becomes plus x, so x square upon root of a square minus x square minus a plus root of a square minus x square upon x square. So then let's just make the denominator common. So we have x square minus root of a square minus x square plus a square minus x square, because it gets squared, upon x square into root of a square minus x square. I took the denominator down. So then we are left with a square minus root of a square minus x square, and we should have an a here. So then x square minus x square gets cancelled, and we are left with a into a minus root of a square minus x square upon x square into root of a square minus x square. That's the final answer. Moving on to the 14th question, we are going to do exactly what we did in the previous one. So then we have square of the numerator in upon this minus this, square of this minus square of this, because of a square minus b square rule. Because we are basically multiplying root of x square plus 1 root of x square minus 1 upon root of x square plus 1 plus root of x square minus 1. So we get x square plus 1 plus x square minus 1 plus 2 into, this is a square plus this is a plus b, a minus b. So we have x raised to 4 minus 1 upon x square plus 1 minus x square plus 1, because of minus minus becoming plus. So again 1 and 1 gets cancelled. We have 2x square and 2 into root of x raised to 4 minus 1. So 2 gets common, and we have x square plus root of x raised to 4 minus 1 upon x square gets cancelled and 2. So just 2. So now our function becomes very simple. X square plus root of x raised to 4 minus 1, differentiation of x square is 2x plus 1 upon 2 root x raised to 4 minus 1 into the differentiation of x raised to 4 minus 1, which is 4x cube. Minus 1 becomes 0 and the 2 gets cancelled. So basically we have 2x plus 2x cube upon root of x raised to 4 minus 1. That's the final answer. Okay, the 15th question is also quite simple. It's root of 1 plus root of x. We know that the differentiation of this whole term becomes 1 upon 2 root 1 plus root x into the differentiation of 1 plus root x. Differentiation of 1 is 0 and the differentiation of root x is 1 upon 2 root x. So basically 0 plus 1 upon 2 root x. So this becomes 1 upon 4 root of x into 1 plus root x. So that is basically x plus root of x, because I just multiplied this term and this term. So we get 1 plus root x into x. So sorry, this should not be, this should be 1 upon 4 into root of x into 1 plus root x. So this will become 1 upon 4 into root x plus x root x. That's the final answer. So that's it for today, guys. Thank you so much for watching. I'll see you in the next video. Bye.